In the previous video, I have started a discussion about the zeros of polynomial, and also I have discussed a general expression for getting the zero of a linear polynomial. As we have seen, there is only one zero for linear polynomial. But now if I take a quadratic polynomial as follows: ax square plus bx plus c. So now how to compute the zeros of this polynomial and how many zeros will be present? So now try to find like this. Since the linear polynomial ax plus b of degree 1, there is only one zero for that polynomial. So now the quadratic polynomial is degree 2. So there are two possible values of x for which the expression may become 0. So for the quadratic polynomial, I can assume that there are two zeros. There are only maximum possible two zeros. So similarly, to compute the zeros, I have to put equal to 0, whole expression equal to 0, and compute the value of x. So now since we don't know how to solve a quadratic equation, I am going to use another approach. As we know that what does the 0 of the polynomial implies? If I multiply, suppose if alpha and beta are the two zeros of the polynomial, I can write the whole expression as follows: k into x minus alpha into x minus beta. This is equivalent to this expression, but I am writing it in terms of zeros rather than this coefficients. These a, b, c are coefficients. A is a coefficient of x square, b is a coefficient of x, and c is a constant term. So now let's see how we can relate the relation between the zeros alpha and beta with the coefficients. Let's see. Let's simplify this expression further. So x square minus beta x minus alpha x plus alpha beta into k. So I can write it as further simplifying kx square minus alpha plus beta x plus alpha beta equal to 0. So now comparing these expressions, these two expressions, we can clearly find that k is equal to a, and also the value of b is equal to minus of alpha plus k into minus of alpha plus beta, and I forgot to multiply the k here. So this is k into alpha plus beta, and c is equal to k into alpha into beta. So these are the relation between the coefficients and the zeros. So now if I simplify further, if I substitute k is equal to a in this expression, then b is equal to minus of a into alpha plus beta. So now I can get the sum of zeros is given by minus of b by a. So don't confuse with the linear expression where if I use ax plus b is equal to 0, I am getting the 0 of x is equal to minus b by a. So here I am trying to find the relation between the coefficients of the variable and the zeros, not the variable and the coefficients. So alpha plus beta is equal to minus of b by a. Similarly, I can find the relation between product of zeros as follows. Again, if I put here c is equal to, instead of k is also equal to a, so a into alpha plus beta. So similarly, I can write alpha into beta is equal to c by a. So these two relations are very important, and we have to know how they are derived. That is very important. And also I will, maybe many of you confused how I have wrote this. I will continue the discussion in the next video. Thank you.